Alright, so for this video, we are going to discuss another new technique for integration, and we name it as integration using substitution. Alright, so there are many functions that we cannot integrate using the method that we discussed previously. So substitution is to change the integration become a simple expression so that we can integrate. Alright, so we call this method as a substitution. Alright, so for our syllabus, substitution question is quite simple because they give you a very obvious hint. Alright, so as an example, like when you see in the question, at the end of the question, they give you something like this: 2x plus 1 equals to u squared, x equals to 2 sine u, and then x equals to sine x. All this equation here actually hints you that you should use a substitution to solve the question. Alright, but only in A level. Because in other syllabus, in higher level maths, when they want you to do the integration by using substitution, right, they won't hint you using this. They won't give you the substitution also in the question. You need to think what is the correct substitution that you should use on your own. Alright, so for A level, it makes this whole process become slightly more easier. Okay, because they already give you the substitution equation that you need to substitute straight away. Alright. Okay, so for the substitution, there's one important thing also, that if you're having a definite integral for a question, if you want to use the substitution method to solve the integration, right, you need to change the limit as well. Alright, so there are a lot of students forget to change the limit and eventually they cannot get a correct answer. Alright, so this is a small reminder for all of you. Okay, so let's have a look for example 19. Okay, so for example 19, right, we have 3 parts here. Okay, so let's have a look for our part A. Okay, so for this one, I will just actually show you the detail. Alright, so the detail of the substitution, and then the method, the process. So for the process of using substitution method to solve the integration, right, the process is more or less the same. Right. Okay, so first of all, we always start from the substitution that they give us here. Our step, first step, you look at the substitution given by the question, and then you can start from here. So let's say I'm having 2x plus 1 equals to u squared. Alright, so first step is always like this. You need to do the differentiation for the substitution equation given. Right, so the first step is you need to do the differentiation. So to do the differentiation, there are a lot of methods. You can use implicit differentiation, product rule, or whatever. It depends on what kind of equation is given here. Right. Okay, so for this one, I will do the differentiation. Differentiate 2x, I get a 2. Then dx. Okay, so dx, usually we didn't write it out. Right. Okay, so differentiate 1, you get a 0, equals to differentiate u squared, you get 2u. Okay, because you are differentiating something related to u, therefore you make it as du over dx. So this is an implicit differentiation that we learned before in chapter 4. Okay, so of course you don't like, then you just use a normal type of differentiation if you want. Yeah, alright, so I'm differentiate with respect to x. Therefore, I'm having du dx here. Then after that, I will try to rephrase everything and simplify. 2 and 2 can be cancelled off. And then after that, I'll move the dx up. So I'm having dx equals to u du. Alright, so this is the very first step that we will do every time. Okay, you do the differentiation first. Alright, okay. Then after that, you will want to substitute all this into your integration. Right, so how can we use the integration, the substitution method to integrate this? Because this equation looks very complicated. We never learned it before. Right, how to integrate? Okay. So first step, you need to substitute all the x. You see that you are having x, x 2x plus 1, then dx, right? your aim is to change all the x here become something related to u. Alright? Okay, so this is your aim. So before you do the integration, you should change all the x become the u first. Alright, so first we will look at this 6x. Alright, so for 6x, I will focus here. For this equation, right, you can write it become what? You can write it become 2x, which is equals to u squared minus 1. Alright, so for this part, what I will do is 6x can be written as 3 multiplied with 2x. And I know that 2x can be written as u squared minus 1. So I will substitute in u squared minus 1 here. Then divided by square root. What is 2x plus 1? So 2x plus 1 is equal to u squared. So here I will substitute u squared. Okay? And after that, don't forget the dx. So how can I change the dx become something related to u? So you can refer here. According to the differentiation that you did just now, dx is equals to u du. Therefore, at the dx part, I will do it as u du. Okay? Then after you get all these things ready, then you can start doing the simplify the expression slowly. So 3 is a constant, I prefer to take it out. I will have u squared minus 1 divided by u, and then u du. Right, so from here, u and u can be cancelled off. And you get 3 integrate u squared minus 1 du. And now the equation just now looks very complicated one. You cannot integrate, right? After you apply the substitution method, change everything become u. Then you see that your equation becomes something quite simple. Alright, then you can integrate from here. 3 is a constant, you just copy. Integrate u squared become u power 3 divided by 3. This is the simple integration. Then integrate 1, you get a u. Then the whole thing plus c. And eventually what you get here is u power 3 minus 3u plus c. But we cannot stop here because your equation now, originally your question is in terms of x. So your final answer should be in terms of x also. Alright, so you have to change all this back in the x expression. The expression in terms of x. Alright, so what is u power 3? Okay, so again, you look at the substitution again from what they give you just now. U squared is 2x plus 1. Therefore, from here, you should know that u is equals to 2x plus 1 square root. So square root is power half. Then you substitute this whole thing into u power 3. And therefore, you will 2x plus 1 power 3 over 2. Alright? Okay. Then how about 3u? 3u means you will get 2x plus 1 power half. Then plus c. Okay, so your final answer should be in terms of x, like what I show you here. Okay, so you can have a look at all the details here. Alright, so all the details here. First step is you need to do the differentiation from the substitution given in the question. Then you have to rephrase, so try to use all the information here for the substitution, for the differentiation, to substitute in your expression, okay, before you do any integration. So you can see that all the x will be substituted into u. You will change it into u. After you change everything into u already, only you start to do your integration. So that's the whole process. the correct, the whole process, the correct flow to apply the integration by using the substitution method. Right? Okay. So if you want, you can after this video, you can try to have a look. Okay, to try the integration by using substitution, right? Based on all this, and try to avoid the substitution by having that involve the trigo one. You should focus on the algebra one first, without trigo one, because trigo usually is also quite complicated. Alright, so to practice all the basic, all the knowledge, you should choose the question that start from the basic substitution first, that involve only algebra first. So after you are familiar with the flow, familiar with the details already, then only you continue, okay, to the integration substitution that involve the trigo. So for this video, I will stop here. Then the substitution that involve the trigo question, I will include it, and I will discuss it in the next video then.